Hello everyone. Welcome back to the session on your sorting techniques in data structures. Today we are going to discuss about one of the important sorting technique. What we do have that we call it as merge sort, and why we are calling it as important because this is the one which we can apply for a longer number of list. Means where till now whatever the sorting techniques we discussed, that is nothing but your bubble sort. Something we discussed about something called as insertion sort. Followed with that, we have also discussed about something called as selection sort. All these sorting techniques, whatever we have discussed here, all these sorting techniques can be applied to a smaller list. Wherever the list is small, there only we can actually apply it. If the list is big, we cannot apply it. So that is what we have discussed till now. And we have seen that the time complexity of these is almost something like quadratic square root, what we get, order of n square. But if we talk about merge sort here, we can apply this for larger applications. I mean, larger set of list. For larger set of lists, we can apply this. And the best part of this particular list is that it takes only order of n log n time in order to complete the task. Well, in the next session, I will tell you this logarithmics, which one is highest and which one is smallest we do have, so that if people can understand which one is greatest and which one is smallest. Means based upon the timing here, order of n square takes much time when compared to order of n log n. So merge sort takes very less time, order of n log n time, and it performs operation. And moreover, the best part is it can be applied for large set of list whatever we are having. For that, we can exactly apply it. So here today we are actually going to discuss about something called as merge sort. As we know that already I told you. So without wasting time, we'll go into the merge sort. Well, we know that this is a sorting technique basically, but it actually uses some paradigm here. The paradigm, what exactly it uses is this one. It is totally based on D and C method. It is totally merge sort is based on DNC. This is a method which is used by the British people on Indians, and they have ruled us from for so many years. That is nothing but dividing and conquering. What they used to do is, suppose there are two kings of two different regions, these British people will actually divide them. Earlier they used to be united, but these British people have divided them separately and then they have conquered it. They know that if they try to attack on India, they will not be able to conquer the entire nation. That's for sure, because the population is very high, even everyone is very strong people used to be. So what the strategy they found is they started dividing them. Dividing in the sense they started separating these people internally. They made these two people fight with each other. When one of them used to lose it, the another one used to be conquered by these particular British people. So both the regions used to come under this particular. So this is a strategy these people have actually used in order to perform it. And the same strategy we are going to do here. So what exactly this merge sort is going to do is divide and conquer. We are having a problem. See, we are actually having one problem, and this problem is very big. Yeah, this problem is very big. We cannot solve it at a stretch. So what we can do is we will divide this problem. We will actually divide this problem into some n number of problems, maybe n by 3, n by 3, or n by 3. Okay, and now we will find out whether this problem can be solved individually or not. If you feel like this problem cannot be solved individually, this is somewhat bigger, then again you people can divide this into again some n sub problems. That is n by 6, n by 6, n by 6, something like this. And you know that this is much more smaller when compared to this. It becomes easy for you to solve, so you will try to find a solution for this. Same way you will try to find a solution for this, and finally you're going to get a solution for the third one. Now you will be combining these three solutions together to get a solution for this particular problem. In the same way you will try to get, so let me call this as solution 1. So same way you will be trying to get a solution for this problem and again this sub problem. Now what you will do, all these solutions what you have got, you will be combining together. Finally, it will be giving you a solution to your main problem what you are having. This is the strategy what we are going to use. So whenever a problem is there, you'll first divide into halves. Okay. So you'll be subdividing them into sub different arrays, and that subdivided problems you will be again subdividing it if it is big enough to solve. Okay, if it is small enough to solve, no problem, you can solve it. But it is very big enough to solve, then you can again subdivide that based upon your requirements, and then you can find a solution to individually to these sub problems, then combine the sub solutions together to get a solution for the previous problem, and then you combine this particular solution together, you get a final solution to this particular problem. What is a major problem you people are having in this particular scenario? So that is what we call it as divide, conquer, and combine paradigm. So divide in the sense, first you're dividing the problem P1, P2. Let us suppose. Now this problem, you're conquering it. Conquering in the sense nothing but finding a solution for that. So S1 is the solution for this particular problem. S1 is the solution for this particular problem, and here S2 is the solution for this particular problem. And finally, you got the solution for these sub problems. What we have to do now? Combine it. What we have to combine? We need to combine the solutions. Once you are combining S1 and S2 together, finally you're going to get the output for this particular problem. This is what exactly happening in this particular scenario. So that is what he's talking about in this case. So that is the basic logic what has been used here. So it is a sorting technique which will be using divide, conquer, and combine. So whatever I explained, this is what he is going to give you technically. So let us suppose there are n element array we are having here. So what we are going to do here is we'll divide this n element array into two sub arrays of size n by 2. As I told you that we have a problem that is nothing but an array. And there are n elements in this. I am going to divide this into n by 2 array, n by 2. Suppose there are 4 elements are present in this, then n by 2, that is nothing but 2 elements here, 2 elements here. Now don't you think that it is easy to solve these 2 elements when compared to solving 4 elements? Obviously solving the 2 elements at a time will be much more easier when compared to solving 4 elements at a time, isn't it? So that is what we are doing exactly here. Next, if A is an array containing, so here what is saying is that in case if a particular array consists of either 0 or 1 element, then you can simply say that the element is sorted, because within an array we are having only a single element called as 5. So you don't have to perform any kind of sorting here because there is only a single element we are having here. So we can say that that particular array is already in a sorted order. So if there are more elements are there, what we have to do? We are going to divide them into two sub-arrays here that are represented as A1 and A2. That is nothing but this is what is calling it as A1 and this is what is calling that. That depends upon the user how they wanted to define it. You people can write it in your own way, however you wanted to write. So no specific thing, but here he has represented like A1 and A2. So after that, what we are going to do is we are going to conquer it. So we have divided a given problem into two sub problems here now, each of size n by 2 and n by 2. Now what we is doing now, we are going to solve them. So here we will be sorting these two sub arrays recursively using merge sort. So using merge sort, we will be recursive. So here we are going to use regression concept. Please remember this. We are going to use something called as regression in this particular case. So using regression, we are going to perform or solve this particular merge sort algorithm. So once we are sorting it up, so these two elements first we will sort it up. We will sort it in an ascending order, let us assume. So the smaller element will come into this location and then the next higher element will be coming in the next location. Same way we will sort this one and finally we will merge these two. And that is what we call it as combine. That you are going to get a output here in this particular scenario. So merging, combining is nothing but merging the two sorted subarrays. Now, as I told you that you people have got, this is a sorted now. You people have sorted it up. So you are having a sorted n by 2 subarray. Here also you are having sorted n by 2 subarray. So finally you will be combining this. So this is something n by 2 plus n by 2. I think you people can know how much you're going to get. So 2n by 2. So that is nothing but equal to n. So this n by 2 sorted array and this n by 2 sorted array, you're combining it. Finally, you will be getting a final solution for your problem. So this is the way how exactly this particular thing is exactly going to work. But there are some things you people have to remember here. What is that is this particular algorithm tries to improve the efficiency. As I told you that this particular merge sort takes order of n log n, which is much very much less time complexity when compared to your order of n square. Okay, so this is very much less time complexity what it takes merge sort in order to sort the elements. So how it is doing it is doing based upon the two parameters it is going to focus on. What are the two parameters are? These are the two. See, you know that if a smaller list we take, it is going to take less number of time in order to sort it. If you are dividing the array into two sub arrays of n by 2, n by 2, sorting this n by 2 is will take much less time when compared to this particular whole array at a time. Same way, sorting this n by 2 will take much less time when compared to sorting the whole array. That is the first tip. Now, as it is taking less time, now you are getting a sorted n by 2 array here. Here also you are getting a sorted n by 2 array. So combining these two sorted arrays together is much more easier and it will take much less time when compared to sorting two unsorted arrays, isn't it? If this is order 1, 2, 3, 4. This is what the array you are having. This is a sorted array, right? 1, 2, 3, 4. Now combining these two will take very less time, isn't it? Because it is already sorted. So what you are going to get output, final output here. So 1, 2, 3, and 4. This is what the output finally you're going to get it. So it is easy to combine a sorted. But in case if it is not sorted like 2, 1, 4, 3 something, again you have to take some time in order to sort it up and then finally you have to get this. So it is going to take much time. So this is the actual technique that it is going to use in this particular scenario. What is that is smallest list will take less time in order to sort it up. Once we have two sorted sub arrays, combining them together to get a final array is much more easier and it will take much less time when compared to sorting two different unsorted arrays. So that is the technique it is using, and because of which the time complexity is here is order of n log n. Now the basic steps what we are going to follow here is something, what is the technique what we are going to apply here, that we are going to see here. Okay, the system hanged a bit. Sorry for the delay. Let me erase it again. So the basic step here is something like if the array is of length 0 or 1, we can simply say that the particular array is already sorted here. Then we will be, in case if we are having more than one element present in that, so we'll simply try to divide that particular array into two sub arrays, okay, or two halves. And now what we are going to do, we'll simply use a merge sort algorithm. We have a merge sort algorithm which will try to divide that sub arrays again into sub arrays, something like this. This is a array, as I told you. Suppose 0, 1, 2, 3. Now first we'll divide that into two equal halves. So you know that first two elements will be coming here and the next two elements will be coming here. Now we will use this, that now how we are dividing this into this particular merge sort is nothing but using this algorithm. We are using a merge sort algorithm that will be coming in the coming slides. Using that only we are divided. Now this particular sub array, this n by 2, this is A1, this is A2. Now this A1 will again will be divided into sub arrays, sub array. How? So since there are two elements are here, so n by 2 will be 1, 1, single element. Now we will compare these two elements. Suppose whatever the elements we have, based on that, again we will try to get a final sorted array. So we will be getting a sorted array here. Suppose here I'm having a value 9 and here I'm having a value 4. So I have separated it. So this is a single array here. This is a single one. Single element. We are going to combine it. And finally, we are going to get 4 and 9. So I'll combine, and during combining it, I'll be comparing, and which one is smallest, I'll place it here. And then the which one is the next highest we have, I'm going to place it. So I got it. Then again, I'll be dividing this also in the same way as a separate, like this. And then again, finally, I'm going to combine. And during combining, I will see which one is smallest, that will come here, something like 5. And which one is highest, that will come here, something, this is 10 and 5. So 5 will come here and 10 will come here. So you can see that there are two different sorted arrays we are having. After that, I am going to use merge algorithm. Yes, there are two algorithms here. One is merge sort, another is merge. What is this merge is going to do? You already got two different sorted arrays now. This will be combined here into a single array. So first this 4 will be selected and it will be compared with the first element here, 8. Okay, sorry, this is 5. So 4 is less than 5 now. So I'm going to place 4 first. Now this value will be incremented here. Now the position is here. Now 9 will be compared with 5. What is the smallest element we have? 5 is the smallest. Now this 5 I am going to place it here. Now I am going to increment the value here. Now this time it is positioning at 10. Now I will compare 9 with 10. Which one is smallest? 9 is smallest. So I'm going to place 9 here, and finally I'm going to place 10 here. So I think you people got it here. So this is what we call it as merge algorithm. So merge algorithm, how we are going to do is we'll finally get two sorted list here. That two sorted list, we are going to check one by one the variables. Which one is smallest, we'll place it in the beginning. And in this way, we are going to sort it up. And that is what he's saying in this particular step. See, merge the two subarrays to form a single list. So we are going to use a merge algorithm here in order to do that. So we will see an example. So, well, I'll just show you an example here, but I will not solve it. First, I'll explain to you people the algorithm, and then I will explain it using that particular example. So here, if you talk about here, I am going to take a unsorted array. If you can see here, so 39, 9, 81, 45, 90, 27, 72, and 18. So these are the unsorted arrays we have. So how many elements we have? So this is 0 index. This is the index I'm representing. 0, 1, 2, 3, 4, 5, 6, 7. So I think you people can understand. So value of n is equal to how much? 8. So there are total 8 elements what I am taking here. So I need to sort them up using a merge sort algorithm. So first, this is the way how I am going to represent here. This is the table or the array what I have seen here. I have represented. Now, before explaining or showing you graphically, I wanted to first explain you the algorithm. Now, this is a merge sort algorithm what we have. You can see here, this merge sort algorithm actually consists of three different parameters. So what are the parameters we do have here in this case is a double r. This is nothing but the array which we have. So how many elements we have in an array? 8 elements. That 8 elements I am passing here. Beginning is nothing but the first index, whatever it is representing. So that is something 0. And end is nothing but the last element is placed in which location? 0 to 7, isn't it? Because in the array, we have 8 elements means we are representing from 0 to 7. So that is what is presented here. Now, first we are checking whether there is a single element in that or not. If it is a single element, we don't have to do merge sort, because if a single element is there, no need of doing sorting at all. So you can simply say the particular array is sorted. So here we are trying to check whether 0 is less than 7 or not. Yes, the condition is satisfied. Now what I'm going to do, I'll find the middle term. What is the mid term for that? So I'm simply going to do 0 plus 7 by 2. How much you're going to get? I think it is something like 3.5. And since we are using integer here, so definitely the value what I'm going to get here is 3. So what is the middle element I'm going to get here is something called as 3. So that is nothing but this is an array. So 0, 1, 2, 3, 4, 5, 6, 7. What does that mean? Now I have divided now. Middle term I have found it. So this is the location. So first four elements, 1, 2, 3, 4. So 0 to 3 is the first. Now you have divided now. So 0, 1, 2, 3. That is what I'm doing. Call merge sort array. Array is nothing but what is the array you are having? Beginning. What is the value of beginning here? 0. But what is you are doing here? This time you're not sending end. You're sending middle term. What is the mid term you got here? 3. 0 to 3. I think you got it. This is what he means to say. So it will simply call this particular, this is a regression. It is calling this merge sort. Why we are calling regression here? We have to divide. Now we have simply divided it. Okay. And next, what is saying in the next step? Call merge sort array mid plus 1. So what is the value of mid here? 3. 3 plus 1 is 4. 4 to n. What is the value of n? 4 to 7. So 4, 5, 6, 7. I think you people now understood that how it is exactly dividing it. This is the way it divides. Now this particular call, okay, let me erase it. Till here, I think you people might have understood. Now here, this particular thing, array beginning and end, again it will be called now. Again, it is calling array 0, beginning is 0. What is the middle term? 3. Now from here, the function will again come back here. But this time the beginning is 0, end is 3. That means he is taking this array now, sub array. Now this will be again divided again. Again it will be divided. Now this time it is checking whether 0 is less than 3. Condition satisfied. Now what we had to do? We simply had to do find the middle term, that is 0 plus 3 by 2. So that how much you're going to get? This is something like 1.5. So you can simply ignore this. We are using integer data type, so I'll be taking 1. So that means again this array is divided into 0 and 1. I hope you people are getting it. Now this time again you're calling this, so 0 1. Again you're sending it here. Now is 0 is less than 1? Condition true. So 0 plus 1 by 2. So what you are going to get? 0.5. So what is the middle term here? 0. So what do you mean by that? Again you're dividing. So this is your 0 and this is your 1. You have separated it. Now after this, when you will check, beginning is 0, end is 0. So this time beginning is 0, end is also 0, because you have divided it. Is 0 less than 0? Now condition fails. You come out of it. You simply come out of that particular thing and then you'll go to the next one. So here that is nothing but merge. So here we are going to call something called as merge. In this case, what it is going to do is it will check the elements present in these two, and based on that it will simply merge it 0 and 1. You got it. Next, again we have another call, something called merge sort array mid plus 1 end. So what is the mid term we got here is 1. So here you are going mid plus 1 is 2. What is the end here? 3. So it means this time you people are coming to this particular location. So this is something 2 and 3. Same way it will be called back again here. So 3 plus 2, how much you're going to get? 5. 5 by 2. What is the middle term? 4.5. I mean, sorry, 2.5. So you'll simply ignore 2. 2 will be your middle term. So again, 2, 3. And again, you'll be calling merge here. So 0, beginning is something 2, middle term is 2, end term is 3. So again, you'll be combining these two. So whichever the values we are having, we'll sort it and 3. And finally, you will be calling again merge here. And when you're calling merge here, this time it will be something array. Beginning is 0. Now this time, what is the midterm we are going to have here? So we are going to this. So what is the midterm we have here in this particular case? 3. Sorry, in this case we had something called 1. So 0, 1, comma 3. So this time these 4 will be merged. So it will be comparing this one with this, whichever is smallest will come here, then next one with next, and finally 0, 1, 2, 3. The elements are sorted. So this part is completed. Now after this, it will again go back to the previous one, previous merge sort. That's why we call it as a regression now. So here this time I am going for the previous merge sort here, where I will be taking 4, 5, 6, 7. Now here also same way merge sort, you'll be calling like this. So initially beginning is 4, ending is 7. So 4 plus 7 by 2. So 7 plus 4 is, I guess, if I'm not wrong, it is 11 by 2. So 11 by 2 is nothing but 5.5, isn't it? So definitely we'll be taking integer now, so we'll take 5. So this will be again divided into 4 and 5. Now this 4, 5 again will be divided as 4, and then it will be divided as 5. Finally, we'll be combining it. You'll be getting the sorted order 4, 5. And same way here also, then it will go for 6 and 7. This 6, 7 again will be splitted up until it is a single individual 6, 7. Again, it will be combined and you'll be getting a sorted. Finally, what you have to do, you have to simply combine it. So you'll get 4, 5, 6, 7. So you got 0, 1, 2, 3, 4, 5, 6, 7 in a sorted order 2. Now you have to combine this. And for that combination, we are going to use again merge. But this time array A. What is the beginning here? 0. What is the midterm we got here? 3. And what is the ending term we got here is something called as 7. Now we are going to combine these two. And finally, you're going to get 0, 1, 2, 3, 4, 5, 6, and 7. I will show you graphically so that you can understand here. So this is the way how exactly your problem is going. So finally, you got a sorted list. This is the way how exactly your program is going to work. Okay, so this is a code for your merge sorts, means splitting. First, what we have to do, divide. That division is done using this particular algorithm. Now we have to combine it now. So for combining, we are using something called as merge. Now this is the diagram you people can see here. This is what we call it as merge. For combining merge, we are going to use this particular looping statements here. Now if you see here, the first looping statement, what you're seeing, the while loop. This is used in order to merge when the number is less than. For example, you're having two different arrays. Now, if this number is less than this, so this should be kept here and this should combine here. But you know that within this particular array, whichever we are taken, that is 8, within the same array, we cannot store the information. Remember that, because this is not a in-place sorting algorithm. In insertion and bubble sort, in selection sort, within the same array, we have swapped the values. But here you cannot swap it. Why? Because you are dividing the original array into two halves. You are dividing the original array into two halves. Then how you can do a swapping here in this array? It's not possible. For this, you people have to use a temporary array. Suppose this is an array which I am using. Apart from this, I am using another array B, and this array will store the values. After performing this sorting and all, one by one, it will store it. Once we are getting the entire list filled up here, we'll simply copy this into this particular array. That is what we are going to do it here. And that is what he's doing exactly here. You can see here, this is what the for the comparison purpose means. If two values or which one is less than, that should be coming first, and then the next one should be, we have to place it here. That will be done using this particular logic. And whatever the remaining right sub array is consisting of, so you have a left sub array, right? So whatever the values we have in this, that will be added using this particular logic. But in case if you're not doing this, the else part will be taking care of the left sub array. This is for left sub array. And finally, the last one, what you people are seeing here, you can see here, while k is less than, this is nothing but looping. So as I told you, I'm going to take an additional auxiliary array, here, some size, random size b, and in this I am placing the values. But these values should be again stored back into the original array which we have taken. So for that, we are using this looping statement, and simply whatever the elements are present in this temp, that I am storing in the original array what I have taken. That is nothing but a double r. This is what exactly how your system is going to work. I'll explain it one more time. So your first merge sort algorithm, this one is the one used for comparison. Comparison and placing which element should be placed first and which element should be placed first and next. Depending upon the sorting technique what you're applying, this is the logic we have to apply. And after that, the remaining elements which are present in the right subarray, we have to copy it. Suppose the right subarray consists of everything sorted order like 9, 10, 11 like that. Then that simply you can copy it. For that copying, we are doing this. In case if that is not the case, then we have to copy the left sub array. Okay, and based on that, you will be combining, you will be getting a single array. Now that is what the elements present in a sorted order in a variable, I mean in an array called as temp. And from that temp, again we have to bring it back to the original array what we have. And for that, we are using this particular looping statement. And simply we are copying the values which are present in the temp into the array. And simply we are performing. So let me explain now this with the help of an example so that you people can get a clear idea on this. Now this is the array, this is the example which I'm taking here. So 39, 9, 81, 45, 90, 27, 72, and 18. Now I'm going to sort it up using merge sort. So this is the way I have represented here. Let's see how you have first what we have to apply. Okay. I think you people know first what we need to apply here. First, we are going to apply merge sort, and this merge sort will divide this problem into sub problems. N by 2, N by 2. This n by 2 again, it will be subdivided into n by 4, n by 4. This again into n by 8, n by 8. Then it will be solved individually combined, Then it will come to that this portion. This will go n by 4 and then n by 4 like this. N by 8, n by 8. Same way. And again it will combine. Then it will divide this. This is the way. So merge sort is used for division and merge is used for combining and sorting them. So let's see graphically. So this is your actually this is the array what you people are having A. I'm using another array also B. This is a temporary array. Okay, maybe something B of 100. So how many elements we have? 0, 1, 2, 3, 4, 5, 6, 7. Nah? Okay, let me take don't not 100. 20, B of 20. So this is a temporary array where I'm going to store the sorted elements. Okay, so in B of 20, I'm going to store, not in A, because this array is going to split up now. So when you apply the merge sort here, what happened now? So it has been splitted. So I told you midterm 0 plus 7 by 2. So how much you're going to get? 3.5. So 3. So 3 is the middle element, this one. So you can see here, this is 39. So 0, 1, 2, 3, and 4, 5, 6, 7. So midterm you got 3. So it has divided now. Now what we are going to do? Now remember, we are going to focus on this. Forget about this. This will come after this particular elements are sorted. After these elements, first we will be sorting these elements. After sorting these elements, then we'll be sort this. So forget about this particular portion right now. So what we are going to do next? So 0, 1, 2, 3. So first we have to again divide them because this is too long to do sorting. So 0 plus 3 by 2. So 0 plus 3 is nothing but 1.5. So since it is a type data type integer, so 1 is the middle term. So this is the middle term. You can see 39, 9, 81 and 45 have been divided. Now again we will enter into this. Now we are going from here to here now. So 39 and 9 will be divided now. So separated. I have separated 39 and 9. Now what I will do, I will merge it now. This time I'm going to use, so merge algorithm is implemented here. And when we are merging, we will sort it. So here 39 and 9 are there. I'm comparing them. So I'm going to compare 39 and 9. Which one is smallest here? Remember, these values I'm storing in a temporary variable called B. This one, this is a temporary variable. In this, I'm going to store the values, not in A. This is A, and here I'm going to use B. So here, which one is smallest? 9. So 9 will come first. So I stored in B of 0, I have placed the value 9. And B of 1, I am going to place the value 39. Since there are only two elements here, I don't have to compare with any other element. Now this is sorted. Now I have to go to the next step. What is the next step? I have to go to this particular location. So this part is completed. Now I'm going to this particular location 81 and 45. Now again I will divide them into 81 and 45. Now again I'll start comparing. I need to merge them. So I'll start comparing. So which one is smallest element we have? 45. That 45 I'm going to place it in this particular location. But this time remember, this also I'm storing in an auxiliary variable here. I'm storing in the auxiliary variable, okay, B. So here I'm storing B here, and then I'm going to store something called as 81 here. So finally, I got two different sorted arrays. Now finally, what we need to do, I need to combine it. So I'm going to combine. So first you might be seeing here, I'm just trying to complete this portion first. Once it is completed, then I will be going to this particular portion. Without that, I'm not going to go to that particular location. So this time I'm going to compare 9 and 45 first. So 9 and 45 I have, sorry, 9 have 45. I have compared it. So first what we are going to do, I'll simply written it here. I'll tell you how it works. First I'll compare 9 with 45 and I'll find out which one is smallest, 9. So this is a temporary variable, right? B. So in this I'll store 9 first. Now this value will be incremented. Let us suppose I'm using I here. Here I'm using J. So I value will be incremented. Now I is representing 39. This 39 will be compared with 45. Which one is smallest here? Third 45 is smallest. So automatically you will be placing 39 in this particular location, not 45. Now finally, now as I told you in the algorithm, left sub array and right sub array, you see that the left sub array is completed now. So right sub array is left and right sub array is already in a sorted order. Simply you're dumping it here, 45 and 81. This is the way how exactly this particular algorithm works. I hope you people are getting it. And now what we are going to do is we'll combine this. Now we are going to combine 90. Now we are going to split. Sorry, this part is completed. We'll come to the second half. So again, we are splitting 92, 27 and 72, 18. Now again, first I'll focus on 90 and 27. I'll split it into two halves again. Now what I need to do, simply merge it. Which one is smallest here? 27. So 27 will be coming here and 90 will be coming here. Then I'll go to the next part. That is something called 72 and 18. I will divide them using merge sort and then I'll combine them. So when I'm combining it, I have to see which one is smallest. That should come here. So 18 will come here. And then finally 72 will be coming in this. And what is the last step we need to do? We need to merge these four elements. So simply, yeah, when you're merging it, first I'll be comparing 27 with 18. Which one is smaller? 18. So 18 I'll be stored in the temporary variable. Now this value will be incremented and it will be pointing to 72. Now I'll compare 72 with 27. Which one is smallest? 27. So 27 will come here. Now this value will be incremented and it will be representing 90. Now 90 will be compared with 72. Which one is smallest? 72, obviously. So it is 72. And finally 90. This is the way how exactly your program is going to work. So 18, 27, you can see here 72 and finally 90. So you can see here you got n by 2, n by 2 from this. Now sorted. This is a sorted array. This is a sorted array. Now simply we have to merge it. And merging that is very, very easy. So here I have shown you practically see here. First element will be compared with 18. And here I'm having a temporary array that is B. That B in within which I am going to store. So 19 and 18 I'm comparing it. Which one is smaller here? 19 is smaller. So I'm going to place 9 here. Then you can see here the value has been incremented to 39. Now I'll compare 39 with 18. Which one is smaller? 18 is smaller. So definitely I'm going to place 18 here. Then what happens, since 18 has come up here, I have to increment this and I have to go to 27. That is what happens here. See, 27. Now I'll compare 39 with 27. Which one is smallest? 27. 27 will come here. Then since 27 came here, it should be incremented to 72. So this time I'm going to compare 39 with 72. Which one is smaller here? 72. So 72 will come here. I mean 39 is smaller. 39 will come here. Now since 39 has come up, now this time this value should be incremented. I value. This is J value. Sorry. This is J. Okay. This is J value here and this is I value here. So I value is going to be incremented now. I will be representing 45. Now 45 I'm comparing with 72. 45 is less than simply 45. Now 45 and now I value is incremented to 81. 81 is compared with 72. 72 is smaller. So 72. Now this time it will be J will be incremented and it will come to 90. So these two we are going to compare 81 and 90. Finally you can come here 81 and then finally 90. So you people got the sorted array and this is stored in a temporary variable B. From B, I have to place them again in this. In this particular array, I have to place because this is the original array, A double R. And this is a temporary array, B, I am using it. From here, it should be stored. For that, you people know how to do it. Simply using a for loop. So in the for loop, you people will be taking one element and you will be posting here something 9, 18, 27, 39, 45, 72, 81, and 90. This is the way how you people are going to solve the particular problem. I hope you people might have understood how exactly this program works. Let me explain one more time with another example here. This time I'm going to take a smaller example, which I have 1, 2, 3, 4, 5, 6, 7 elements I'm having. So total 8 elements. So you can see here, first it will be dividing, merge sort will be dividing and you'll be getting this half, first half, left half. And that left half you'll be again dividing into next two parts, 38 and 27. This 38 and 27 you are split it. Now this is the smallest problem you have. Simply now you people will be calling here merge and you'll be combining these two. So I am selecting these two. I'm finding out which one is smaller. So 27 will come first and then 38. Merging is done. Then I'll go to the next part. So where 43 and 3 I am going to take. This I'll split it up into individual one. Then I'll start comparing these two and then again in a sorted order. Now what I have to do, simply merge. Now I have to merge these four numbers. So first I'll compare 27 with 3. Which one is smaller? 3. So I'm storing 3 value in a temporary array. Then 27 will be compared with 43. So 27 is smaller. Done. Now I'm comparing 38 with 43. Which one is smaller? 38. So I'm going to place 38 here. And then finally 43. And this part is completed. Now first half is completed. Now let's go to the second half. So here, since how many elements are left? 9, 82, 10. 3 elements are there. So we have to split it up. And when you're splitting it up, it's very easy how you can find it up. So 0, 1, 2, 3, 4, 5, 6. So 4 plus 6 by 2. So that is nothing but 5. So this is your middle term. So this 2 will be split up into single piece and this will be separated as a single piece. See? 982. Now first we'll split it up into halves. Then we will be combining it 9 and 82. And then finally 10. Since there is only one element, you don't have to do anything. Same you have to represent. And now we'll be combining these three. So first I'll compare So first I'll be comparing 9 with 10. So which one is smallest, that will come. 9 will come here, and then we'll be comparing 82 with 10. Smallest element is 10. So I'm going to place 10 in auxiliary variable, and I mean array, and then finally 82. So you people got the sorted two sorted arrays, you have got it. Now simply have to merge it. And when we are merging, you'll be comparing 3 with 9. Which one is shortest? 3. So you're going to place it under temporary array. Then increment 27 will be compared with 9. 9 is smallest. Now it will be incremented. We'll compare 27 with 10. 10 is smallest. We have placed it. Then we'll be incrementing 27 here. I mean, sorry, 10 will be incremented. Means the position will be incremented and it will be representing 82. So we'll compare 27 with 82. Now you know that 27 is smallest. It will come. Now that will be incremented. We'll compare 30th with 82. Now 82 will come up here, and finally 43. And after 43, nothing is left, only one element, 82. So finally you people got this particular element. Now all these, whatever you got, will begin storing back into this particular array, original array, simply using a for loop. Okay, I hope you people got it. This is the way how your algorithm is exactly going to work. It's a very simple, but only thing, the merge is somewhat bigger one, which you people have to identify, which you people have to practice it so that you people can understand how exactly it works and remember that how to write the particular logic. Now, if you talk about the performance analysis of this particular algorithm, as I told you before itself, since it is dividing the input array into two halves and solving them recursively, and after solving what we are using merge in order to combine them together. So the worst case time complexity for this will be something order of n log n. Even for the best case, it will be order of n log n. And even for the average case, you people are going to have order of n log n. But the only difference what you will find here is the space. The space complexity. As I told you, I'm going to use a temporary array, isn't it? I have used a temporary array here, and that temporary array is what will be represented here as a space complexity. So what is the temporary array we are using here? What is the size here is the number of elements which I am sorting here, that much array I'm going to take. That many spaces are required. For example, earlier the value of n is equal to 8. So I need to use a temporary array where 8 elements can be stored. So that is order of n. The space complexity is order of 8. Suppose you have if you are giving n equal to 100 elements, then what is the space complexity here is 100 spaces are required. Additional spaces are required in order to store that particular elements. Okay, so this is the way how exactly it works. And the thing people have to remember here is the complexity. So even in the worst, best, and average case, the complexity of this particular merge sort algorithm is order of n log n. It's very, very less when compared to order of n square. That I will explain it during a normal break time whenever we have. Then I'll explain, I'll give you the order, how to remember which one is smallest and which one is biggest. And this is all what we have for today's session related to your merge sort. So I hope you people have understood this particular logic. If you have any doubts, you people can ping me up anytime. So this is all for today's session. Thank you. Thank you for watching.